Welcome to the Real Flat Earth Friday, October 17th. How are you doing this evening, brother?
I'm pretty good. I'm excited for tonight. I'm a little disappointed that this all didn't go down in an actual formal debate against McToon and Craig McNeil from Fight for the Flat Earth. But here we are anyways, and I'm excited to still get this information out.
Yeah, for people that have been following along, this was supposed to be a three-part debate series where the first one was going to be us debunking the 12 so-called experiments in Antarctica. The second one was us showing how the stereographic biblical virtual reality, the SBVR model, actually explains all 12 of those so-called experiments. And then we also proposed we've got 12 totally, completely different types of heliocentric or spaceball debunks, and we're going to be going through those tonight. So the difference between us and Will is his 12 so-called experiments, there was only 3 different types of experiment being talked about. 10 of them were the exact same thing, meridians getting smaller in the south. So there was only 3 topics. We're going to be going through 12 totally different topics tonight. And I think anybody that pays attention is going to learn something tonight. There's some new stuff being brought out. There's a whole nother category of limitations to how far that we can see that we've never talked about before that we're going to be getting into, and I'm excited about it. What else can people expect from this?
Yeah, so getting into the different debunks, and these are just 12. Right? There's many more than this. But what people need to understand is that this information is for you to back check, for you to research, for you to, get familiar with, right? We're not trying to hide this information so that we can get some kind of gotcha. It just is what it is, right? And when you do the research and you go out and you test these things, you're going to find out what we found out, right? And if you can come to a higher level of conclusion or more information you can add to it, if corrections need to be, we'll be happily corrected. But what I've found over the last 10 years of my researching the shape of this realm and the physicality, quote unquote, of it, is that these are the things that I can stand on and argue and debate anyone in the realm. And we'll gladly take a challenge on. For anybody that wants to debate, leave a comment below or email Jason and I. All the links are in the description box. You can find us in Telegram at the Reality Check chat. You can get involved there. There's also the Team Yahawashai chat. You can get involved in that Telegram group as well. And we got new news. Today, ChatGPT gave me an idea on how to ask for appeal to fight for my YouTube channel. And it's been 3 years and they accepted my appeal. So my YouTube channel has been put back online. I'm pretty excited about that. They won't let me chat in the chat tonight, unfortunately. But it was only a few hours ago that I actually found a spot where I could apply and sent them the application in. And so there's a good chance that there'll be a rise and grind on the Limitless channel. We'll see how that goes. I remember before they took me down, I would get like 5 viewers. So I might still stay on Rumble. We'll see. Maybe I'll simulcast to both locations. But I'm excited to be back on the Limitless channel. I put the link in the chat, and I'll put a comment below if they allow me. Yeah, it's amazing. I'm shocked, but I'm super grateful that ChatGPT gave me a really good way to appeal. So if anyone else has lost their channel, I'll put the description of what I said below, and you can copy and paste it and change it to your name, your channel. So anyways, let's get on past that. We've got so much to get into tonight with these, just the first 12 heliocentric spaceball debunks.
We do. And so like I said, there's new information that's gonna be brought out here. You're gonna learn something. I learned something as I was putting this together. And yeah, some of our old staple debunks that we've been using forever, things like how there would be no 90-270 sunrise sunset at the equator, at the equinoxes with the heliocentric system, because of the tilt of Earth, the 23.5 degrees. That would negate the ability to have the 90-270, plus how the sun wouldn't be able to do horizontal circles at the poles. these are things that we didn't even put into the 12 different debunks that we have of heliocentrism. I think you're going to be surprised at some of the new ones. Some of the old ones we're continuing to use because they're just so strong and so solid. But each and every one of these is a full stop end to either geocentrism or heliocentrism. And what we're really going to be putting to people here is there's only been 3 different options for how you can describe day and night on Earth. And that's the geocentric, heliocentric. For a while, there was the pressurized pizza dome where you had the horizontal sun doing circles going away from you. And there's been the virtual reality where the sun rotates around the observer based on the latitude on a fixed and stationary plane. But it's in a virtual reality construct, not an atomistic Big Bang type world. So we're going to be going through this information. It's going to be up to y'all to make a choice on how you explain day and night. And you're down to just 2 choices after the whole Antarctica thing. So hopefully once we show you all these debunks, even if there's some sort of shadow of doubt in your mind as to, oh, maybe we're still on a spinning space ball, hopefully you'll see some of these things are glaring impossibilities, and it'll tilt the table for you. Is there anything you want to get into, or should we get into the 12 debunks?
Let's go.
All right. So we do have a document. If anybody's interested in it, I could put it to Google Drive, but we're going to be going through this document here that I've assembled with the help of research from ChatGPT. And we are going to have debunk number 1 being no measurable curvature, and the formula is wrong. All right. This is a 2-in-1 right here. So globe defenders often cite the shortcut formula of 8 inches per mile squared to calculate Earth's supposed curvature. But this formula is not the true geometry of a sphere. It's just an approximation that only works over short distances. When we use real geometric measurements, the actual drop is 16.6 feet per mile for the first 24 miles. That means at just 1 mile, the ground should already be over 16 feet below the observer's head, below the observer's eye level. By 2 miles, over 33 feet. By 10 miles, more than 166 feet. And by 24 miles, nearly 400 feet of drop. To put this into perspective, a 1-story house typically has a roof peak of about 16 feet tall. That would have its roof at the observer's feet if it were just 1 mile away. Yet in reality, we never observe such curvature in towns, neighborhoods, lakes, plains, or coastal views. Roads, railways, rivers, and skylines remain flat and level, not diving away under our feet. So the punchline, if there were truly curved 16 feet per mile, it would be visible and undeniable within just a few miles of any observer. The fact that it never is seen makes curvature an illusion, not a reality. So we have this graphic here. You'll be able to see a whole bunch more of this in a podcast that we did, and where we actually showed this is a SketchUp 3D model that is to scale. All right, so 3959 miles. This right here is 3959 miles, and then all of these circles are drawn at different radii to be able to. This is a tangent line being placed right here. So then what you can do is measure from the tangent line to the curve and get an actual measurement. And so we've done that, and we've come up with this table, and this is something that anybody else can do the exact same thing yourself. You can use a CAD drawing program, you can use any sort of 3D modeling program, and the difference is actual geometry, that's circles, lines, things like that, as opposed to a formula like 8 inches per mile squared. So in this chart right here, we have the actual geometric measurements from a 3D modeling program. 16 feet, 7¼ inches is actually 16.6 feet if you turn it into a decimal. The formula everybody's heard of before, 8 inches per mile squared. There's a huge difference between in 1 mile being 16.6 feet of drop as opposed to 8 inches. A lot of people can slough off that 8 inches and act like they would never see it. But when you start realizing that the peak of a house just 1 mile away from you would be at your feet, and then at 2 miles, a 2-story house with a really, really steep roof, right? 33 feet would be at your feet in 2 miles. And then all of a sudden at 3 miles, once we're at 50 feet here, we're talking a 5-story flat roof building, 5-story commercial building. 4 miles, 6.5-story commercial building. These things, the top of it would be at your feet if we were actually on a curved ball with a said radius. This is the geometry. And you can see here that the 8 inches per mile squared, I mean, the largest error of margin is in the beginning. So it's 95.98, almost 96% wrong in the first mile. And then it starts to get closer and closer and closer. Notice here that the first 24 miles are all 16.6 feet. And then it's not until the 25th mile that you start getting more and more drop per mile. But you can see here that it's really right around mile 100 that all of a sudden 8 inches per mile squared becomes relatively accurate to geometry. And then as you go beyond that, the error increases again. And what's the issue with it being correct at 100 miles? Well, that's truly about the limit of how far we can see on Earth. You know, it's not too much further that Mount Everest has been seen. About 125 miles is the farthest sighting of something on Earth. So the curvature formula is super underinflating the amount of curvature that there is geometrically. And if you actually go by true geometry, it would be obvious to everyone. There would be no question. We wouldn't be saying, oh, Earth's flat, because you could literally see the curvature in these first 5 miles real easily, super easily. When somebody said, where's the curve? You'd be like, there, there it is, right?
Yeah. So,
and go ahead.
So what they've basically done is they've taken approximation for the radius in the curvature formula, and they've given it because it sort of starts to work past 100 miles where we actually can't see. But what they've done is they've hid the actual way that it would be observable and measurable on the local 1 to 10 mile scale. And it doesn't surprise me. It's another one of their tricks that they've been doing for a very long time. It's not surprising that you're the first one that actually has gone and done the geometric measuring in the CAD programs. I'm hoping that other channels will actually do the measurements too and verify what you've done.
Mm-hmm. Absolutely, yeah. When the thing is I'm just using SketchUp 2017. Somebody's got to have some AutoCAD program out there that has much higher resolution, because once you start doing geometry, you start to realize that there is no such thing as a perfect circle, and that it all comes down to what resolution are you measuring at. And yeah, so things like AutoCAD, you might get set of 16.6 feet, and you might get 16.61574 or whatever, or some thousandths of an inch type measurement. I just wanted to point out to everybody, this geometric curve versus formulas is a podcast that we did March 28th, 2025, where we go through and systematically show these measurements where you can double check and verify for yourself. But like Ron was saying, build the model yourself, use AutoCAD yourself and test it and see that the geometric curve be way more than what they say in the 8 inches per mile squared formula.
That's right.
So that is the debunk of heliocentrism based on, we would see the curve based on a 3959 radius.
On a
It'd be
local
easy to-
scale. We're
Yeah.
exposing the fact that it's actually 16 feet drop in the first mile, right? 16.6, not 8 inches per mile squared, right? And again, we challenge anyone out there with modeling programs to do the measurements yourself. Okay, so let's get into point number 2. This happens to be one dear to my heart. I've always been in love with water. Whenever we got to the cottage, the first time I would get down the dirt road, the first thing I would say is, there is the water, the lake. That was what interested me. And why is that so important? Because water proves that we live in a level, flat, stationary plane, not a curve. It's not curvelled. Water is the standard of level. Water at rest always finds a flat, level surface. This is why water levels, construction lasers, and transits are universally calibrated against water, right? You can check your laser level to see if it's out by simply taking a tube and holding one side up to the wall and marking it, filling it up with water, and then holding the other side up till it stops overflowing and put a mark on the other side, and then spin up your laser level, and you'll be able to verify if that laser level is true due to the way that water levels out, okay? Dams, bridges, canals, and runways are surveyed and built to flat planes, not curves, right? There's a huge distinction here. Level does not equal curve. It's not curvel. There's two different words here, level and curve. A horizontal plane is defined as flat, perpendicular to the plumb line, the z-axis, in a Cartesian grid. If something curves, it is no longer a plane. It would be a hill, different word than
Parabola.
a parabola. Yeah. There's many other ones that aren't on the tip of my mind. Saying level curves around a sphere is an absolute contradiction, right? It's like saying a straight circle. Okay? It's dumb. Okay, move past mind tricks and idiot word games. Okay, why gravity, almighty G, isn't the answer. Spaceball defenders invoke gravity, which they define as mass attracting mass, to explain why water supposedly clings to a spinning ball. But this has never been observed in real life, ever. Cars don't attract cars. Ships don't pull other ships to it. And buildings don't lean into each other, except for the one in Italy, the Leaning Tower of Pisa, right? Nothing has...
And tugboats pull ships too, right?
Rocks and pebbles at the bottom of a mountain don't climb up the base of the mountain. It's ridiculous to think that they would. Okay, in a virtual reality model, right? A programmed creation. When I say virtual reality, I mean in a reality in a world that was programmed, with the lack of the better term, programmed into a virtual reality that your soul, your eternal being, is consciously piped into, sort of like the way the Matrix showed it, okay? In the virtual reality, there is no gravity. Instead, objects fall by a fall-drop algorithm, again, programmed by the creator. It wasn't a happenstance of billions of years from an explosion that created everything from nothing. That's ridiculous. Programmed variables include true weight, volume, surface area, air pressure, buoyancy, etc. The algorithm produces the effect we see as falling without needing imaginary mass-to-mass attraction, which again is not observable in any way. There's no experiment. There's no demonstration. The Cavendish experiment is a joke. He hung 2 lead balls from a shed roof hundreds of years ago and then went outside with a telescope and then said he was somehow able to measure the 2 pulling themselves closer together. And from that measurement, he then deduced that he could weigh everything in the known universe, at least in our solar system.
Yeah, I just want to hit people with this real quick. So if you create a virtual reality or a video game where you've got a person carrying a box, right? Carrying a box. And in this game, you want to drop the box. Well, in the program, the person carrying the box, it's moving with the hands. You have to have some sort of an algorithm so that when he lets go of the box, that the box goes down and at a certain rate, right? That is the physics of a fall drop, algorithm. And it's all based off of these metrics right here. And it's not based off of mass attracting mass. That's
No. And if you'd
clearly
like,
not the algorithm.
and to get more information, I refer you back to our last podcast on Wednesday where you went, or was it last Friday, where you went more into detail into the different parameters that are involved here. There's surface area. There's a few things that add into the equation for anybody that wants to geek out on a little bit more of that stuff. I like the simple stuff that everyone can understand, like the hard limits to word games. Listen, we're not here to play word games. Okay. We're not speaking in parables right now. We're giving it to you straight. If level meant curving around a sphere, then water levels, lasers, and construction transits would all be useless in the real world. Okay, we're builders. We build things. That's what we do for a living. We don't have coffee mugs, t-shirts for sale. We don't shill out $3,000 or $7,000 per post. We build things, and this is what we do because we love the truth and we love to investigate our reality. In practice, listen, water levels, lasers, construction transits all work because Earth is flat and level. That's the only way that they could. Okay. Punchline, pay attention. Water and instruments confirm that level means a flat plane. The attempt to twist it into a curved level or curvel is rhetorical trickery. Rhetorical trickery. And Rid's retarded and all these other guys that are scared to debate us. That's all they have is word games and lies, okay, to defend their spaceball model. It's not an observation of reality in any way. In the virtual reality world we actually live in, falling is governed by a programmed fall drop algorithm. Okay, eye level. Okay, the horizon, it always stays near our eye level. Number 3. And why? Why it shouldn't. If we lived on a sphere or on a ball, right? The horizon would be constantly in all directions. We don't live on a cylinder. You wouldn't just see curvature this way. You would see it all around you. And the higher you went, the further that curve would drop down. Okay. Eye level. Number 3, the horizon stays near eye level. And why it should not on a space ball. Okay. The horizontal plane through the observer, your XY plane in the VR framework, an apparent horizon, resolution horizon. The furthest resolvable edge of the ground plane in your view. That's the horizon, okay? It's where the surface detail becomes unresolvable due to finite angular resolution / contrast. That's a new part that we're going to be bringing in today that no one's ever heard before. Jason, you're the first one to bring it out. So the ground visually merges into the sky band. Now, you can learn and investigate these things if you study photography and film work and other things where it's just known practice. They don't really discuss it being the way that our reality works. It's just the way that cameras and vision functions. Okay. Ball model geometric horizon on a sphere. The horizon is a tangent circle below eye level whose depression angular increases with altitude. That means drops away from, right, Jay?
Yeah. So if you were in a hot air balloon going straight up, the moment you took off from the ground, your horizon would immediately be descending. And this depression angle will increase with altitude. So the higher you go, the more you have to look down, the more you have to look down. And all of this is immediate.
Yeah.
Immediate. As soon as you start rising, it starts going down.
And larger and larger. Not, pull up a picture of a tiny little bit of a curve, because when a camera is pointed up, the horizon line will curve, and when a camera's pointed down, it'll be convex. No, you would see curvature everywhere. It wouldn't be we can debate over the angle of the camera. Okay, in a 3D rendering, this is what actually happens in our virtual reality. A flat ground plane projects outwards until it meets what's called a vanishing line, which tracks near eye level as we ascend. Okay. However, because eyesight and cameras have finite angular resolution and contrast limits, the lowest angle ground detail becomes unresolvable first. The lowest detail, the parts at the bottom. That loss of resolvable detail occurs below eye level. So the apparent horizon does drift slightly downward with altitude. Not much, slightly, and still continuing to be perfectly level, right? All around to a plumb, perfectly, not slightly curving. Result, the horizon stays near eye level, not perfectly, but this is exactly what perspective resolution limits predict on a flat plane. Why this contradicts the spinning spaceball claim. In a spaceball, spinning, render the geometric horizon must drop noticeably as altitude increases. It's the tangent to the curved surface. It doesn't increase your field of view while continuing to stay flat and plumb and parallel. It would drop. it would drop drastically. Jason's going to show you now in a 3D modeling program exactly what's taken place.
Yeah, so this was originally in the Flat Earth River Proof, my first Flat Earth proof video. And it just so happened that I had gone through the effort of putting, you know, a globe Earth in here. And I was doing these measurements for the river proof, which we'll be coming to in a little bit. But I wanted to show people here that in the 3D modeling program, so once I've got myself centered in and I'm coming into this point, and what am I saying here?
I'm going to take the hand. Ooh.
Just look at the drop.
The moment I start pushing this Earth down, the horizon is immediately,
you know what happens?
immediately descending
on a ball.
Right, it doesn't stay up near eye level
horizon
ever. As soon as you go up in elevation,
go down below you. Okay.
The ball horizon will go down
here,
around you.
Infinite flat plane in that.
So on a flat plane, you will get a situation where it doesn't remain perfectly eye level, and we'll be explaining all of that. But it stays very close. Right, so this is representing a flat plane right here. This is representing a geometric space ball. And if we go back here, the moment you ascend,
we're standing at the river mouth.
The moment you ascend on this.
Now picture yourself in a hot air balloon at that river mouth, and you're gonna ascend upwards. So here I'm gonna take the hand. Ooh.
Oh,
you know what happens?
It only goes
As
down.
you rise.
That's it.
Back to the document. So the key mechanism here in a plane world, all right, perspective sets the horizon near your eye level. Finite angular resolution, though, causes a slight apparent drop with altitude or height. In the ball world, space balls spinning, geometry requires a growing depression angle below eye level as you rise everywhere around you, always. You would know if you were on a spinning sphere when you took off in a plane, in a hot air balloon, when you climbed the top of a mountain, you would know.
You would know. Debunk number 4, gyroscope evidence. What a truly free gyro would show on a ball. A rigid in-space gyro referenced to your starting level should tilt relative to the local level as you move over a curved surface. This is just common sense. The required pitch down change to keep following the curve of a globe of 3959 is this 0.0145 degrees per mile. You have to maintain that in order to follow the curve of the ball. So 60 miles, that would be 87 degrees. 1,000 miles, 14.5 degrees. Half of a globe, 12,450 miles. This would be 180 degrees. So if you started out on one side of the Earth and you were to fly 12,450 miles in a straight direction, your gyroscope should be upside down at that point. All right, that's what a gyroscope does. It remains rigid in space, and they're saying that they've gone upside down once they've traveled halfway around Earth. So what aircraft instruments actually do, this is where it gets a little tricky because there's a lot of propaganda regarding this. So legacy altitude indicators, we're going to use AI for short here, were marketed as rigid in space, but in service they include erection caging systems, that's the pendulous vanes, mercury switches, acceleration sensing jets. Now I got to say, none of that stuff existed when they first had just spinning gyros. All that is technology that's been added along the way, and what we care about is the rigid gyros originally that have no other contraptions or add-ons or software included, just a rigid in space gyro.
But we're not limited to that speech. We can get into super detailed explanation / debates into all of the pendulous vanes, mercury switches, acceleration sensing jets. We have we understand exactly what they're doing and how they work and exactly why they actually, you know, don't work the way that you think that they do. Anyone like Dave McKeegan, again, we're accepting challenges to debate any of these topics.
Yeah, see, what they say is that those things continuously force the gyro to align with the local plumb z-axis, which they say is changing. We say that z-axis does not change. It's plumb is plumb everywhere on the plane. Modern AHRS, INS, these are the ring laser gyros, fiber optic gyros, MEMS, IMUs, use sensor fusion, rate gyros, plus accelerometers, plus magnometers, plus air GNSS inputs. You think of your phone. Your phone has the X, Y, and Z built into a motion sensor in it. It's got the accelerometer. It's got a lot of these things. When you set your phone down, the sensors should show that it's not moving, right? Because it's stationary. But the rest of the spinning spaceballers say that no, it's whizzing through space, and it's just being zeroed out as it spins through space. Filters constantly re-zero pitch roll to the local vertical, what spaceball defenders attribute to their gravity, mass attracting mass. In our virtual reality framework, it's the fall drop algorithm defining the local z-axis. Bottom line, these instruments are engineered to show level relative to the immediate local plane. Wherever you go, they cannot reveal cumulative curvature. They are designed to cancel it. So because of what they've done, saying that they have pendulous vanes and Mercury erector switches, all these kinds of things, they literally can't prove that they're on a spinning spaceball because it's always zeroing out.
Yeah,
right?
Somebody would have taken a flight with a non-assisted gyroscope and showed you that it was out 180 degrees after flying halfway around the Earth. They would have done it a long time ago. There wouldn't be a debate. The fact that they add these things, and what they don't tell you is most of them have been added for the military, right? And the reason they do that is so that if they have some type of maneuver in the air and the gyro suddenly becomes out of place, they have ways to sort of kick it back into its position. Right. And they cheat and they lie and they use these things to try to quote unquote prove that you live on a sphere. Listen, the debate about the shape of our reality, it's been going on for a long time. These plans were put into place as people realized, like long before social media, people were pretty intelligent. Like my grandparents and your grandparents and our grandparents' grandparents were a lot more street smart, right? They weren't easily as fooled as we are now today, sadly. And what they were doing was, as they were coming out with these inventions and these new devices, they were also paying scientists and really intelligent people to come up with ways to turn a proof of the Earth being fixed and flat into a supposed sphere curvature type of a proof. And all you have to do is actually, slow down and look carefully at the information, and you can see exactly how and why they did these tricks.
Absolutely. So what the data shows in practice, pitch traces. If you're not familiar with this word, lock it in. We're going to be showing you a graphic showing a pitch trace in flight data. This is the data that comes from the black box. For cruise legs, show nearly steady pitch, a small positive pitch tied to AOA trim across hundreds of miles with no cumulative nose down trend of 0.0145 degrees per mile. The flight profiles are climb, cruise, level, descend. The level portion is flat relative to the local plane, not a visible ever increasing nose down attitude. So let's go ahead and take a look at one of these pitch traces. And so it's hard to find this stuff. This is NTSB data. They do publish this type of information when there's a fatal air crash. And a lot of them are blurry and hard to read. I was only able to find a couple decent ones. So I just wanted to show everybody on a pitch trace like this, what do you got? Well, you got the pitch A. So this shows 0, a plus 30, and a minus 30. and you can see that this airplane, when its altitude went up, here's your altitude right here. We had the pitch. It was pitched up, right? And then to level out right here, this was the altitude where it just had this light little bit of pitch up right here. And this is actually when this flight was at its fastest airspeed. So it had its lowest nose pitch. And then you can see this flight slowed down right here. And then once it slowed down, it had a little bit higher nose pitch. So this is just simple physics where once you're going really fast, you can keep your nose down, right? But when you're going slower, you have to have a little bit more pitch. But what do you see here on this graph? This is across a flat plane. The only way that you could show this pitch data going around a curve is you would literally have to plot it around a curve. You would have to see a curve here, and then you would have to have this pitch angle going around the curve. When you do this on a flat plane, it's proof that you're going over a flat plane. And then you can see what happens out here at the end, and the plane crashed.
Yeah, well, the measurements are literally taken from a flat baseline. They're not measuring off of a curved sphere, let alone also taking into topography into account. Right? These are very complicated data that we're looking at, and the data does not show the plane pitching around a sphere. It doesn't show it having to nose down so that the planes don't fly into outer space. Okay, it's ridiculous that anyone can't see this. It's simple. It's really simple.
Yeah, there's the pitch data right there. So reframing the claim and cutting through the rhetoric, spaceball defenders say AIs stay level because of pendulous vanes, mercury, accelerometers that make the gyros precise as you fly around the ball. Translation, the instrument is actively forced to track the local z-axis everywhere, so it will always read level regardless of whether the surface beneath the plane is a plane or a sphere. So you cannot use flight data to prove that you're on a spinning spaceball. That makes the AI non-evidentiary for curvature. It is explicitly designed to mask any inertial tilt that would accumulate over long distances. That's the reason why we want them to just do a straight up old-time mechanical one and show it precise, right? Let it precise. We want to see it precise.
And show us, right?
Debunk, and the thing is, you don't have to be flying to do it. You could literally have, if you had a gyro spun up a half a day later, it should be upside down in your house, right? Because they say Earth's spinning. Debunk the claim that avionics data supports Earth being a ball. The expectation of free gyro on a ball would have the 0.0145 nose down accumulation per mile, which would be 87 degrees and 60 miles, 14.5 degrees and 1,000 miles. Reality, avionics, legacy AIs, and modern AHRS erect to local z-axis continually. No cumulative tilt shown. Data the long cruise legs show steady pitch, not a mile by mile pitch down. Conclusion, gyros and AHRS are built to stay locally level, so they cannot be used as proof of curvature. Their behavior is fully consistent with level flight over a plane. Key points. Where is the cumulative nose down in the pitch trace? A device engineered to re-zero to local z-axis can't prove globe curvature. It's literally designed not to show it. Show a free non-erecting gyro logging 14.5 degrees tilt after a 1,000-mile leg. Otherwise, your claim is just instrument design, not evidence. Proposed fair test. Mount a truly free gyro. Log raw gyro rates with all vertical alignment corrections disabled and fly a long straight cruise leg. Prediction the ball 14.5 accumulated nose down after 1,000 miles. Observation, the real ops, instruments don't show this because they're forced to track local level. In the virtual reality framing, instruments align to the drop fall algorithm's z-axis, producing the same level indication without invoking mass attracts mass. So everywhere straight down is perpendicular on a flat plane.
Yeah.
There is no accumulated tilt of a spinning gyro.
Like a cross, you have this marker that you can move around in three-dimensional space. You have a flat plane and a plumb line. Those two things are the most important parts of our virtual reality for navigating, for mapping, for just navigating just through this reality. You just need those different axes. And we're going to be getting into a really exciting part, number 5, right? This one.
Well,
what?
How about you want to take a break here quick?
I thought you wanted to go to 7, but we could take a break. Yeah, absolutely.
Well, we've got 2 breaks to squeeze in still before the end.
Let's do it.
Welcome to the Church of Zeros. Rejects, rejects. Look around, this God's my witness. Crypto, grifters, misfit toys and twisted sisters. Broken cradles, we will catch the fallen angels. That you belong here. Creatures of chaos, that's how they made us. We are contagious, the future's afraid of us. Creatures of chaos, love it or hate us. If you're feeling dangerous, that means you're one of us. Mischief makers, shacked up punks and misbehaviors. Freaks of nature, non-prescription meditators. Yeah, you belong here. Creatures of chaos, that's how they made us. We are contagious, the future's afraid of us. Creatures of chaos, love it or hate us. If you're feeling dangerous, that means you're one of us. Yeah. Psychos, sickos, we will catch the fallen angel. Creatures of chaos, that's how they made us. We are contagious, the future's afraid of us. Creatures of chaos, love it or hate us. If you're feeling dangerous, that means you're one of us. Look what they've done to us. The future's afraid of us. The future's afraid of us. The future's afraid of us. The future belongs to us.
I
We are back.
cannot believe that it's Theory of a Dead Man. I haven't heard them in a long time. I was at Nickelback's concert. I actually got to meet them, and Theory of a Dead Man was also playing with them that night when they got these big record. They outsold Rush, Nickelback. I know a lot of people don't like them. But let's get into this content, everybody. Point number 5. This one you really want to get familiar with. Okay. The acceleration, deceleration, composite motion debacle, trochoid path, tilt-a-whirl logic. I know it's a little bit hard to chew on. I know. Okay. What this demonstration proves. Are we going to go to the video first? Is that how
Yeah.
you wanted to do it? Okay.
Let's go ahead there's two things right together back to back. This first one was the gyroscopes, and then the next one is the trochoid path. So let's check this out quick.
Planes do not process. Original gyroscopes used in air travel had no electronics and did not process throughout journeys. The gyroscope of an airplane unassisted by electronics would process 90 degrees with each quarter of the sphere traveled. The artificial horizon indicator would be upside down 180 degrees, having flown half the circumference of a globe Earth. For the defendants to claim sphericity, they must demonstrate both an unelectronically assisted gyroscope process a full 360 degrees during a circumnavigational flight and throughout a full rotation of Earth from the ground. Globe debunk number 5. Earth is motionless. For Earth to rotate with the motions defined by heliocentrism, we could feel acceleration and deceleration as demonstrated in this experiment. Not only do we not feel, nor can we measure any acceleration and deceleration, but Ares failed to detect any movement of Earth whatsoever. We demand the defendants provide measurable, repeatable evidence for the acceleration, deceleration, and movement of Earth, without which the heliocentrism.
All right, so that was a description showing something at the surface of a spinning ball that's in motion, right? So if you want to continue here.
Yeah, okay. So a spinning wheel, right, plus forward motion produces a trochoid or epicycloid-like path, okay? Even if the spin rate and the forward speed are constant, the dot speed in space, it oscillates, accelerates and decelerates, because its velocity is the vector sum of two motions. And don't even get me started on the moon, all right? Don't get me started on the moon. You don't have enough shekels in the bank to get me to go on that. Maybe we'll do a bonus 13 at another point on the moon. So the path's curvature and the dot speed, they're not constant. The continuous lateral acceleration is due to turning, plus tangential acceleration due to speed oscillation. Map the demo in the Spaceball's claim. So on the surface, the observers on a spinning space ball are like the marker on the wheel. Daily spin, or your local rotation around the axis. That's 1 day on the space ball. Annual orbit, Earth's center moving around the sun. That's moving in its elliptical path that they say, right? Often added solar system or galactic drift. Superimpose those, and the geometric path of a surface point becomes a trochoid-like wiggle along the larger orbit, or like a tilt-a-whirl style. Constant direction changes in cyclical speed modulation relative to the inertial space. Translation, or layman terms, the claimed kinematics are filled with acceleration, both directional and speed-wise. This is a geometric consequence, not an appeal to instruments or old experiments. What is ridiculous is for the Spaceballers to deny that we would feel acceleration and deceleration if Earth followed the path described by heliocentrism. Let's just slow it down here. If the Earth were spinning once a day while flying in an elliptical orbit around the sun, there would be acceleration, deceleration. There's no way around it. It's not a fixed relative motion in one direction. If you're in a car and you're turning one direction and you crank the wheel and turn it in another direction, you're going to feel that. You are absolutely going to feel it. And don't let anyone tell you that you're not, because they're just playing mind games on you, okay? Spin plus forward motion, trochoid. This means accelerations and decelerations are literally baked into the cake of reality. If you ride a tilt-a-whirl, you feel it. You feel it, right? The composite rotational changes both your direction and your speed, okay? Even with a constant spin and a constant forward speed, the vector sum of motion makes your actual speed oscillate, right? It oscillates on the path that curvature may vary. As you can see here, nicely laid out on the wheel with marker, the blue line, right, is the acceleration, deceleration, and the green dot is the constant motion forward through quote unquote time. Then we get the beautiful spaceball equivalent daily spin annual orbit wiggly path that you'll generally see fake single pole pressurized pizza dome or Freemasons put on the screen and say, we live on a pizza because look at how pretty these little swirls. No, that's not what we're talking about here. We're talking about 0.5, which is acceleration and deceleration, okay? Motion debacle. Trochoid path, tilt-a-whirl logic, okay? Closest matched, spin on spin. So Jason, I know we're going to get into, you've got some other clips. So why it matches. Cars freely spin. Now we're talking about a tilt-a-whirl. Do you want to show the video or do you want me to read the points?
Just give us some points and then I'll show people what we're talking about.
Okay, so cars on a tilt-a-whirl freely spin while their platform orbits and rises and falls. So there's multiple changes in direction, right? Composite rotation with changing curvature, classic tilt-a-whirl. As it spins, it tilts and whirls, right? So here's your official page, Larson International.
Here is a tilt-a-whirl. Most people have seen something like this.
I hope you've been on one.
So you have two spins here. You have your cart that can spin around this way and the whole thing's rolling around. And then it's got the humps, ups and downs like this.
Yeah, it shows the
So this
trochoid.
isn't, it's not a perfect representation of what we would, heliocentrism says. So what's the next one?
So the next one is a scrambler, the sizzler. Right.
Yeah. So why it matches, the rider car spins on an arm. The arm rotates around the center. Let's take a look at, here is the scrambler.
Here we go. It's a little glitchy.
Now all of a sudden we have something that's actually moving similar to what the heliocentrists say. We
Absolutely.
have these flat horizontal cars where it would be the person in the car like this would be like a person on Earth spinning, and then the going around would be like the yearly path as well. So that shows perfectly the acceleration, deceleration that takes place with that type of path.
Everybody would know. We'd say, oh, we're in decel time, everybody. Make sure you get out and start to have fun. Oh, we're starting to go into XL, batting everything down. The next example is the teacups, right? I vividly and fondly remember when I was younger, the teacup ride at Canada's Wonderland, where I grew up. Why it matches the three rotations, the cup, the turntable, and the pad and the platform, right? Spirograph and epitrochoid families.
All right, we've got a funny one here where somebody actually tried to show what it would be like on Earth in order to hit like 1,000 miles per hour and 66,000 miles per hour. So let's check this out.
Starting teacup engine.
So this right here is our G-force measurement.
20 RPM, 50,
Here we go.
80, 100,
7, 9G, 10G, 13G.
150 RPM,
Starting table engine.
All right, table engine now.
20,
Watch our G-force go up.
50, 60.
You see what's happening with the head here? This is what would be happening to us if we were spinning at 1,000 miles per hour and 66,000 miles per hour at the same time. Our heads would be looking like this.
Well, the surface of the Earth's surface would be doing that everywhere, right? And the faster you are, the more on the equator you were. So now we got number 4. We get the octopus, monster, spider, spinning hub, up and down arms, often spinning cars. Why it matches, okay. Hub rotation, arm motion, plus car spin, layered rotations with varying curvature, strong wiggle analogy, right? We look at this and we can understand what's taking place. It's not hard.
This right here would probably be the closest representation to Earth. So go for a ride on this thing. That's what it would be like,
Crazy.
right?
Absolutely.
Here's a couple other ones that show what it would be like to be on a spinning ball Earth.
This one represents
Power
the moon.
surge built
A
by
little closer.
Actually, yeah. Well, this one is sort of strictly just being on Earth.
Zamperla. This
'Cause it
Zamperla
doesn't-
creation is a must-do for any
Because it
adrenaline
doesn't
junkie.
have
This
it
1999
doesn't have the
creation
table
delivers
rotation.
non-stop
Speed
excitement.
up and slow down.
Once in action, the power surge unleashes a sequence of electrifying movements. This machine features 6
The next
robust
one.
arms that
The next
extend
one is
outward,
really
each
probably
equipped
the
with 2
best.
seats at right angles. As riders buckle up with over-the-shoulder restraints,
there you are
their
on
legs
Earth.
dangle freely. Then the arm assembly begins to rotate. Soon
There's the
afterwards, the
ride.
main arm springs into action, twirling both sections and causing the attached seat sets to swing and rotate around the central point. The power surge guarantees a unique and intense adventure. Prepare to be thrown into a world of pure excitement.
Let's check out the next one. Here we go.
Manufactured
Pure
Tivoli.
fantasy.
If you love spinning at steep angles, this ride will leave you craving more. This attraction closely resembles the classic orbiter in its design. Much like its predecessor, the ride consists of articulated arms extending from a central vertical axis.
There.
Each arm
all
has
they
a
did was just mimic heliocentrism right
Boom.
here, right?
Done. So as everyone can see, this demonstrates the way that this heliocentric spaceball reality falls flat on its spherical face. I'm sorry, let's move on. We got number 6, Jason. These are going to be some good ones. Number 7, make sure everybody, you're going to want to, sit down and stay tuned for that. But number 6, river flow.
Uphill. So this was my first spaceball debunk. So let's lock in our definitions. Sea level is a baseline. It's fixed, straight, unchanging. Level, it's straight. It's not curved around a sphere. Down equals the fall drop, the z-axis on the VR. Water at rest forms a level surface. What the spaceball geometry requires, not a claim about reality. If Earth is a sphere of radius r, after ground distance d, the surface has fallen away by the sagitta. Right? Am I saying that right?
Yeah, I think you got tomato, Sagitta, Sagitta. You got it right.
Sagitta. Your case. This is a reference to the river proof video. I was living 143 miles from the coast, and that distance right there would be 13,632 feet of drop using the 8 inches per mile squared. The geometric drop, not the crude 8 inches per mile shortcut. Your home elevation of 400 feet above sea level. The implication is from sea level at the river mouth, looking inland along a local tangent, the home should be 16,632 feet below my feet out at the coastline. The implication from sea level at the river mouth looking, I read that. In that geometry, the river must go up 13.2 thousand feet towards me. Reality check, measured river profile, what we actually see, the river's average grade is 2.8 feet per mile. Over 143 miles, that's 400 feet of total drop down to sea level. That's a typical of a gentle river. And in symbols, water surface elevation decreases downstream. That is a monotonic down profile, no uphill segment towards the sea. Why level curves around a sphere fails operationally. In practice, level is set by water levels and straight laser digital levels in construction, surveying, and hydrology. If level truly curved, a scale fluid column would stay level while climbing around a convex rise, purely due to mass attracts mass. No working scale law or demonstration shows this. So rebranding level as curved is definition bending, not field physics. A fair modern field test, simple and repeatable, establish a straight reference with your linked water levels or a digital level line along a long river reach. Log elevations with this as a cross check. VR prediction, a monotonic down profile to the coast on a straight baseline. The spaceball burden would be to produce an equivalent scaled rig where a fluid column remains level while ascending a convex surface without graphics or model assumptions baked into the instrument. Our challenges and rebuttals: pick any long river on a straight sea level baseline. It runs down a few feet per mile. The spaceball geometry demands thousands of feet up over the same reach. Water levels and laser levels define level as straight. Saying level curves just changes the definition to fit the model. Show a scale demo. If water stays level and climbs a convex rise, show it. If not, the curved level claim fails as physics. Notes and edge cases: local wiggles, rifles, pools, dams, or tidal backwater near a mouth can flatten or briefly reverse flow, but the longitudinal water surface reference to a common sea level baseline remains non-increasing toward the ocean. We are talking about the water surface, the hydraulic grade line. Water will pool or erode until that profile reaches sea level.
So it's pretty basic, right? Water cannot flow uphill. It doesn't do that. It doesn't. Now, water does do supernatural things. Like it can, it's attracted to what I've seen, the sun. Sunlight is able to pull water up through plants, right? But water does not flow uphill. So what we could also use as a last point before we move on to number 7, which is probably the most complicated spaceball debunk. Let's just quickly talk about the Suez Canal. If you don't know, the Suez Canal is a 120-mile long canal, and it's an artificial sea level waterway located in Egypt, and it connects the Mediterranean Sea with the Gulf of Suez. And guess what? It doesn't have any lift locks. There's no devices. There's nothing stopping it from running its water either way. And there's zero curvature allowance in its construction. It's a literal 120-mile, just carved out path. And the water, it just sits in it level, the whole 120 miles. So don't come and tell me that you think you live on a spinning sphere, because if Jason was to do the math, if you were to measure this, is it Sagittarius, the bulge?
The bulge.
The bulge in 120 miles, the water would have to rise up the bulge. And not only that, but the water would have to rise up in all directions, because there is no up or down direction on a sphere. Everything is relative to everything else. The fact that we have rivers and the Suez Canal without any lift locks or dams, showing that the water remains perfectly level and flat, shows us that we live on a flat plane.
Number 7, gravity versus SPVR, the Z-axis fall drop algorithm. The core contrast: the spaceball gravity, mass attracts mass, invoked as a universal patch, oceans glued upside down, tides, spins, orbits, one word to rule them all: gravity. SPVR equals a fixed down vector, the Z-axis of a 3D Cartesian grid, a fall drop algorithm that actually determines how objects move when released. No motion, then release, then computed fall. Definitions we control. So gravity, the spaceball claim mass attracts mass, is used as a blanket excuse whenever the model needs saving. SPVR down is a plumb vector normal to a level plane. The physics engine computes fall using known variables: true weight, volume, surface area, air pressure, buoyancy force, etc. At rest, in the SPVR, objects aren't moving. No acceleration exists until the fall drop event is triggered. Why the spaceball claim is incoherent. The strength paradox. The same force is said to be strong enough to hold entire oceans to a globe upside down, yet weak enough that a butterfly trivially overcomes it with a few wing beats above those oceans. Blanket excuse behavior. When curvature is missing, refraction plus gravity. When rotation is unfelt, inertia plus gravity. When scale breaks, gravity wells. This is rhetoric, not a predictive pipeline. No scale demo. If mass attracts mass, Explain oceans on a convex surface. Show a scale experiment where a fluid column adheres to a convex object by mass attraction alone. No containers, no spinning, no pressure tricks, while nearby small flyers still escape it effortlessly. The SPVR fall drop equals predictive and testable. The down axis, the fixed Z towards a level stationary plane. The algorithmic fall, the inputs of the true weight, surface area, volume, air density, pressure, buoyancy force, drag. Output, a precise time, position, velocity history for the drop. Explains reality we actually see. At rest, sensors read a static down. No lateral rotational accelerations are present until motion is induced. The release, the objects begin to move only when the fall drop routine runs, and their rates change predictably with shape, area, and air. Parachute versus pebble, feather versus ball. Fluids, behavior follows pressure plus buoyancy rules on a level baseline. No curved level. What Cavendish actually did, a torsion balance with small lead spheres on a light rod near two larger lead spheres. The rod's tiny twist angle was viewed with a telescope through a window to avoid disturbing air in the shed. From the observed twist plus fiber constant, Cavendish computed a value that later maps to G, the gravitational constant. They literally say that Cavendish was able to weigh Earth with that telescope and lead balls. Our critique, why the premise is faulty, point by point. 1. Non-isolation in a gravity world. If a real universal mass attracts mass force pervades everything, then the entire shed, ground, walls, hills, groundwater, tides, passing carts, body heat, and the Earth itself are in play. The experiment conflates a minute signal with a sprawling, uncontrolled background. Environmentals dominate microtorque, thermal plumes, air currents, electrostatic charge on the balls or the fiber, magnetic contamination, seismic, traffic vibration, barometric swings, and anelastic creep in the fiber all generate drift and bias at exactly the scale being measured. Model locked readout. The apparatus assumes an ideal Hooke-Law torsion fiber, a linear restoring torque, and a clean inverse square geometry. The attraction is inferred by fitting drifty angles to a pre-chosen force law. The observer analysis bias. There's no blind protocol. The experimenter knew where the big masses were and watched for the right direction of twist. With minute signals over hours, confirmation bias is a real risk. Earth is a constant third mass, a universal field strong enough per spaceball to keep oceans stuck to convexity is treated as a non-issue while we chase micro-radian twists from nearby lead balls. That's not clean isolation, that's background subtraction by assertion. All right. This is the big new one. What do you say we take another break here?
Yeah.
And then we'll go through and we'll wrap this up.
Yeah, no, I'm excited. And again, we're going to publish this in a pinned comment below for anybody that wants to slowly read this. And, you know, we're always here to talk about all these things. And we're hoping that you on the other side of the screen can go further with these debunks and observations.
But this is the big new information coming up. So come back, y'all.
Feel it. Forget is a strength I'm yet to learn. I can't bury my head under the sand and hope it makes me feel less. How the hell do I pretend? Just tell me it'll make sense in the end. I can't lie to myself. It fucks with my head. I just wanna be fearless. Paranoid, hearing voices from above. You destroyed every piece of me I ever loved. And you never noticed. I'm trying to hold you down. Used to care what you thought of me, but now I don't. Will you be there when I need you? Now I guess you won't. So I'll roll the dice, see you in paradise. I guess I'll have to wait my time. Forgiveness is a strength I'm yet to learn. I can't bury my head under the sand and hope it makes me feel less. How the hell do I pretend? Just tell me it'll make sense in the end. I can't lie to myself. It fucks with my head. I just wanna be fearless. You're chasing miracles. It's all so cynical. So I won't try to confess, but just wanna be fearless. Can't lie to myself. I can't lie to myself. I guess I'll have to wait my turn. Forgiveness is a strength I'm yet to learn. I can't bury my head under the sand and hope it makes me feel less. How the hell do I pretend? Just tell me it'll make sense in the end. I can't lie to myself. It fucks with my head. I just wanna be fearless, fearless, fearless.
We're back.
We're back.
And we are at debunked number 8, which originally was just about ships going away and disappearing bottom first. And we had another one that was similar in angular resolution, and we didn't want to have any repeating debunks. So what we did is we lumped all of the visual factors into debunk number 8. And this one is typically, the space ballers say, hey, that boat going away, it's disappearing from the bottom up, it's going over a geometric curve, is what they say. So our modern core claim is that the bottom first disappearance of ships, buildings at long range is a sampling visibility limit of the visual system plus optics plus atmosphere on a flat baseline, not proof of surface curvature. As range increases, the lowest, finest, low contrast details at the waterline hit the perception floor first, so the bottom goes before the top. Change the vantage, that would be the eye height, and the object reappears consistent with the square root of the height, horizon expansion. Mechanisms, stacked and testable. Angular resolution threshold. This is a real thing with a formula. Features smaller than an arc minute are unresolvable. That's the human eye's vision resolution limit. And the bottom rails, the hull line, the deck edges have the smallest angular subtents and vanish first. Now, if you pay attention, if you have a big ship, you'll see it getting smaller and smaller and smaller. Things like rails on the deck, all these different types of things, they will go out of focus and be unresolvable, even though you can still see the bulk of the ship. Maybe, you know, the top drive cabin, right? The contrast extinction. This is the new point that I don't know that anybody's ever really talked about. So contrast extinction near the surface. The low angle path skims the boundary layer. That's where haze, aerosol, turbulence, contrast decays exponentially with distance. Waterline features wash into the sea background before higher, brighter superstructure does. Then there's the surface roughness, the occlusion, wave mask. That's distant wavelets form a grazing ocular. Their apparent vertical size shrinks slowly, so at long distances they mask the lowest pixels of a ship even on a flat plane. Then there's sensor sampling and blur, the finite pixel pitch, the line spread function. Atmospheric scenes smear the target where the vertical pixel budget on the ship is just a handful of pixels. The lowest rows blend into the water texture. Perspective geometry. Equal physical heights compress into an even smaller angles with distance. The rate of shrink is harsh at the bottom near the horizon line, so bottom detail reaches 0 arc minutes first. Predictions: how to falsify or verify a flat baseline. Raise the eye height. Increase the observer's elevation. The horizon distance expands. The prediction: parts that were gone reappear without changing the target, consistent with perspective plus the square root of height, not your fixed physical bulge, which would have different angles. Things would be tilted away or towards. Improve clarity. On exceptional clarity days, lower extinction, the same range reveals more bottom than on hazy days because contrast floor moved out, not because the ground flattened. Increase the optical scale. A longer focal length, real optical zoom increases image scale per pixel. When atmosphere allows, you recover a few more low rows, we're talking of resolution, pixels, before they drop below the 0 minimum. Digital zoom does not help. Wave state dependence. Higher wind or waves increase the occluding mask at the same distance. You lose more bottom on rough days than calm days. So the minimal math. We're not doing super hard math here. The angular size divided by distance gives you radians. Bottom features have smaller angular size and cross the minimum threshold first. Horizon growth. This is the square root of the height in feet, giving you the distance in miles. Raising eye height moves the visibility boundary outward, allowing reappearance without moving the ship. The contrast law. Contrast. This formula here we're going to go into in depth and explain. This is the thing that nobody's really talked about. Once below the detection threshold, features disappear regardless of geometry. The brightness drop. This is the inverse square law. Light only travels a certain distance and it gets lighter and lighter and lighter until it hits a unresolvable where it's not enough light to be detected anymore. Every doubling of distance reduces light intensity by a factor of 4. The inverse square law being used. The anticipate and parry, for the people that say refraction did it, the response: refraction is real, but here's the mechanism of blur contrast loss. Not a magic bulge remover. Note how clear day data outperforms hazy day data at the same distances, matching a visibility model, not a geometric hump. Zoom can't beat the curve. Response correct. Zoom can't create new information. But when atmosphere is the limiter, more image scale lets you use what light you do get, often restoring a few more bottom rows exactly as predicted by sampling plus contrast, not peaking over a bulge. Why bottom first? Response: because bottom features have the smallest angular size and lowest contrast against water, and they sit behind the wave mask. That triad forces bottom first loss on a flat plane. This can be mimicked in a mall. This can be mimicked at a big box store. All right. So here's our big things that we're going to be going through. The perspective geometry, the foundation of the illusion. The apparent horizon is the point where ground detail becomes too small to resolve, merging into the sky band. On a flat plane, parallel lines converge and equal heights compress with distance. Anybody ever seen telephone poles that are all the same height converge to a point at the horizon, forming a vanishing line near eye level? This horizon rising to eye level behavior is built into all 3D render engines and camera projection systems, including those used by the SBVR. On a spaceball, the geometric horizon should drop noticeably below eye level as altitude increases. Yet in every real observation, it doesn't. In reality check, the horizon only drifts slightly downward with height due to optical resolution limits, not curvature. Number 2, angular resolution. This is an actual formula. The visual cutoff point. Human vision and camera optics have finite resolving power governed by the Rayleigh criterion. It has 2 factors: wavelength of light and aperture diameter. It's that simple. Light has a wavelength to it. The longer wavelengths, which would be like your reds, they get cut off first. The shorter wavelengths, which are your blues and violets, they are the shortest and they get cut off last. But it all comes down to what is the size of the aperture. So humans have an aperture that's like this big. Cameras have apertures that are like this big. But once again, the inverse square law is at play. So you can't really make super huge lenses and get that much better resolution. So the human eye's resolution limit is 1 arc minute. That's 1/60th of a degree. At 10 miles, details smaller than 15 feet vanish. You get that? That's
They're just
something
gone.
15 foot tall on a flat plane at 10 miles. Angular resolution cut that off. At 50 miles, even a 75-foot tall object blends into uniformity. Can't see it anymore. Therefore, when the bottom of a ship disappears, it's not because it's going over a curve, it's dropping below the angular resolution floor of your optics. The lower parts vanish first because they subtend the smallest angles, not because the Earth is bending away. All right, so this is the big new one, the fun one. We're going to be learning something here. Contrast extinction. This has to do with the atmospheric opacity. Light passing through the air loses contrast exponentially. This is the Beer-Lambert law used in optics, photography, atmospheric science to describe how light and contrast decay with distance. As light travels through air, tiny particles, aerosol, dust, water droplets, pollution, scatter and absorb some of that light. Every small segment of air removes a fraction of the remaining contrast, not a fixed amount. But the loss happens fractionally and continuously. The rate of loss compounds, producing an exceptional decay curve rather than exponential decay curve rather than a straight line. So here is the formula. It looks all big, bad, and ununderstandable, right? Here's the factors. You have the initial contrast. It's unitless. The contrast of the object when viewed up close, full strength. For example, black versus white, 100%. This is the most amount of contrast possible. Black versus white. And then you have the observed contrast. This is the contrast that you actually see after the light has traveled through the atmosphere. You have an extinction coefficient. They label it beta. This is per kilometer, per mile, whatever you guys like to use. It's a measure of how opaque the air is, how strongly it scatters or absorbs light. So high beta is hazy, low beta is clean air. The path length, kilometers or miles, the distance between you and the object, and then Euler's number, the mathematical base of natural logarithms used whenever a rate of change happens continuously, like decay, absorption, or population growth.
So just want to point out here, it's really, really, really easy to observe this. All you need to have is a clear day and a view that you can see beyond 5 miles. And what you'll start to see beyond 5 miles is you'll see a milky haze to whatever objects that you're viewing in the distance. And here in Texas, in Austin, we live in the hill country. So sometimes we have a really good distance at up to 10 miles, and you can clearly see where the band of haze begins. This is something that's repeatable and observable by everybody.
So here's an example calculation. We've got one. This is a perfect black-white contrast. We've got the beta. This is a moderately hazy day, and we have a distance of 10 kilometers. We get this result right here. That means that only 36.7% of the original contrast remains after 10 kilometers. We're talking about something that started at a perfect contrast. Only 6.7% of the original contrast remains after 10 kilometers. So here's a table that'll help put this into perspective for people. Very clear mountain air. Here's the factors that you can use. This is the visibility range. So on very clear mountain air, you can see 50 kilometers. You can see 31 miles. This is a rare crisp blue sky days, high altitude or post-storm clarity. Then if you have clear sea air, these are your factors. And then all of a sudden your visibility is reduced to 20 to 30 kilometers, which is 12 to 19 miles. This is good coastal visibility on dry, low pollution days. This is a limit because once you hit a contrast where all contrast is gone, there's nothing to distinguish between one thing and another. They literally look the same color, right? No contrast means you can't identify it. Moderately hazy day, 10 to 15 kilometers. That in miles is 6 to 9. This is common mid-latitude or humid conditions. Heavy haze. It's going to be 5 kilometers, 3 miles. This is thick humidity, industrial haze, or fog layers. So, how much contrast is lost per kilometer of air? This is the same decay rate expressed per mile. Faster decay equals shorter visibility range. Visibility distance roughly follows the point where contrast becomes 2% of the original. Once it's just 2% of the original, there is no contrast left to be able to see it anymore. So even in the clearest air on Earth, visual extinction limits sight lines long before any geometric curve could. They're saying just the fact of looking through the air under these conditions, you couldn't even see far enough to see the curve, right? Quick recap, we have our starting contrast, we have how hazy the air is, we have the viewing distance. This shows the remaining visible contrast. The exponential comes from the continuous fractional decay. The brightness drop. This is another factor. The inverse square law. Every doubling of distance reduces light intensity by a factor of 4. Distant objects dim below both human and camera detection thresholds. Combined with atmospheric scatter, this guarantees that the lowest, least reflective portions vanish first. Light fades geometrically, ground doesn't curve. So the brightness drop equals the inverse square law times the atmospheric loss, what we were just talking about in the contrast part. So this is the formula for being able to see if something is bright enough to be seen anymore. And I can point out a few things here. We have our different symbols. The E is the illuminance at our eye in lux. So this is what we're measuring, how bright something is. This is like the end result that you're measuring. The luminous intensity of the source is measured in candela. The distance to the source in meters or feet and miles if you want. The atmospheric attenuation, we just went through that with the contrast extinction. So we have rules for can I see it? So first you have to choose a detection floor. What can be, measured and seen. And this 10 to the -6 lux is considered like the bottom threshold of what is able to be seen as far as a light is concerned. So here we have some examples. Case A is 1 candle. All right. So in a perfect condition with no haze whatsoever, the max distance that 1 candle can be seen from is 1 kilometer or 0.62 miles. Under clear conditions, but a little bit of haze coming in here, then it's visible up to 0.95 kilometers or 0.59 miles. Moderate haze, 0.89 kilometers, 0.55 miles. Now let's jump up our power of instead of having 1 candle, let's go 1,000 candela. So under no haze, it'd be seen 31.7 kilometers or 19.7 miles. And then under these atmospheric conditions, it would be reduced like this. Now let's jump this up to the max. Let's go to lighthouse class beacon, 1 million candle power, no haze. It would be able to be seen 1,000 kilometers or 621 miles, but then with the different hazes applied, knocked down to these distances. Now we do know that you can't see a lighthouse, even if it's 1 million candle power, 621 miles, because all of these things have to fit together. It has to be within the circle of sight as well. So in case there's any sort of confusion, the candela is the luminous intensity. That's how bright the light is in a given direction. A lumen is a total light output, but in all directions. So a lot of times people hear about lumens, and then you're wondering, well, what's a candela? This has to do with the brightness of the light in a direct path. So intuition with examples, laser like spotlight has low lumens, but very high candela because it has a tight, intense beam and it reaches very far. A bare bulb, high lumens, but low CD. The light spreads out everywhere, not intense in any one direction. So a flashlight comparison with 1,000 lumens with a wide beam, 60-degree beam, that's a modest candela. It's a good flood, but has poor throw. 1,000 lumens with a narrow 5-degree beam has a very high candela and a long throw. And the bonus term lux, this is the illuminance at a surface. So these are the things that are measurable and have formulas for, in effect, whether or not a light can be seen, right? Is it bright enough to be seen at the distance that we're being told? Then the other factor is surface occlusion, the wave mask. At long distances, foreground waves act as grazing occluders. Even 6-inch surface chop can mask several feet at a distant hull at the resolution limit. Varying wave states perfectly explain why the same ship appears taller on calm days and cut off on rough ones. No curvature required. The circle of sight. This is one of the other factors. If something's not in the other circle of sight, it can't be seen, like we were talking about with a lighthouse. So in the SBVR framework, the visibility boundary forms a circle of sight determined by the observer's height and optical limits. The distance in miles is equal to the square root of the height in feet. Geometry sets the maximum reach of our line of sight on a plane. Optics define what remains visible within that distance. An example, 100-foot eye height, the horizon is 10 miles. Another example, 400-foot eye height, the horizon is 20 miles. Two observers at 20 feet height each can't see each other beyond 10 miles total. Think about that. All right, so you have two people out in the Bonneville Salt Flats, and they each have a 25-foot step ladder, and then they set those ladders up 10 miles from each other, and they can't see each other on what we know is a perfectly flat plane.
Yeah, that kind of goes against people that believe they can see too far, which we've been arguing vehemently as strong as we possibly can for a very long time, that it shows like will not be named anymore, that will go around saying we can see too far when you can't. Okay, that's not the way that this reality works.
These relationships work perfectly in real measurements and VR simulations and collapse entirely under the curve model. So these are the extra factors. We talked about the big four. It has to be in the circle of sight. It has to be bright enough to be seen, and it has to abide by the inverse square law on that. It has to have enough contrast to be able to be seen. And the angular resolution. So all of these things are limiters, plus these are extra ones that are limiters. So we have diffraction, the minimum resolvable angle. The eye at night has a pupil of about 7 millimeters, 20 to arc seconds best case. Daytime pupils smaller, worse diffraction. Atmospheric turbulence, so random blurring, scintillation. Practical point spread is also often 1 to 3 arc seconds. Worse near the ground, water, and heat shimmer. There's a reflection layer and mirage. Thermal gradients bend rays, smear, shift, stretch targets near the surface, and can both hide and reveal slices. Air mass geometry. The near the horizon you traverse 8 to 10 times the air, more scatter. Glare and veiling luminance, the sky brightness. So bright backgrounds, twilight, city glow, the moon's glow, raise the noise floor. Contrast must beat the sky brightness per arc minute squared in your field. Dark adaptation and pupil dynamics. Full scotropic adaptation takes 20 to 30 minutes. Large pupil helps brightness but worsens aberrations and halo. Contrast sensitivity. The eye resolves best around 3 to 6 cycles per degree. Very fine or very coarse detail needs high contrast to be seen. Retinal sampling and crowding. So the cone spacing in the fovea limits fine detail. Peripheral crowding makes small targets near other textures hard to detect. Accommodation, focus error, and aberrations. Tiny defocus or astigmatism crushes fine contrast. Cheap lenses or the human cornea add coma and halo around points. Temporal factors, motion and integration. The eye integrates over 80 to 120 milliseconds. Fast target camera motion equals motion blur. Flicker, twinkle can drop effective SNR. Surface occlusion and wave mask. We've talked about that. Wavelength dependence. So it depends on what color light you're dealing with, because the longer wavelengths get cut off first, the shorter wavelengths last. Now, binocular, when you have two eyes, you actually get a little bit of a boost, but it's not a game changer. And then you have some camera specific things. So pixel scale, the pixel pitch plus lens quality sets the smallest cycle degrees the system preserves. Exposure and ISO noise. Low light pushes ISO. Noise eats contrast. Then you have stabilization and shutter. So shake equals blur. Long lenses demand fast shutter or tripod. And compression sharpening can fake edges or smear real micro contrast.
So basically that's how we're able to see the distances and all the variables and the reasons why we can't see too far, and how we see, and the way things are basically coded into this reality. And at some point, we will work on short forming these down, and we'll have a hard hitting short form version. This was us getting it all out there so that it can be shared. I'm going to take over here, Jason. I'm going to read 9 and 11. You can do 10 and 12, maybe. So,
Sure.
number 9, NASA's credibility problem, right? This has to be brought up because when somebody thinks they live in a spinning space ball, they generally use NASA as their evidence. When an agency asks for extraordinary trust, in its own words, and history must clear an extraordinary bar. Here are 4 specific citable credibility issues to put before the audience. Don Pettit's on-camera quote about lost the moon tech. Quote, I'd go back to the moon in a nanosecond. The problem is we don't have that technology anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again. Context here. NASA points to NASA's own oral history pages, emphasizes Apollo, know-how and spin-offs, but do not retract the quote. The agency's explanation is generally that the hardware factories and production lines were retired, not that human knowledge vanished. Use that contrast to stress public-facing message versus internal rationalization. You can cite, there's a link here that we can go to. Number 2, NASA openly uses CGI in their imagery, right? NASA's Blue Marble releases explicitly credit compositing and enhancements. They're data mosaics and renderings, not a single full disk snapshot from low orbit of Earth. They're 3D renderings, right? 3D composites of a globe. NASA staffer Robert Simon, nicknamed Mr. Blue Marble, describes his job plainly. I turn data into pictures, data-driven visualizations. Used to distinguish measurement, processing image from a traditional camera. NASA's Scientific Visualization Studio exists to create visualizations, animations, and images, including a published CGI moon kit for 3D renderers. This is an official workflow, not a rumor. Use that fact to demand clear labeling whenever composites or CGI visualizations are shown to the public. Number 3, documented Masonic affiliations among astronauts. Symbolism debates aside. Examples, everyone recognizes Buzz Aldrin, clear Freemason, documented by Masonic organizations, and helped charter Tranquility Lodge number 2000, a Texas lodge named for its lunar landing site. This is not an accusation. It's a matter of record. Right? Use it to argue the elite fraternal networks overlap with space institutions more than the public actually realizes. Number 4, and last point on NASA, Jack Parsons. And we could go way, way deeper. We could talk about so many things, right, that NASA has to deal with that they don't anymore. But let's just finish on Parsons, a seminal figure behind JPL, Jet Propulsion Laboratories, pre-NASA, was simultaneously a pioneering rocket engineer and leading practitioner of Aleister Crowley's Thelema, OTO, a well-documented by Smithsonian level and academic outlets. The point isn't moralizing, it's transparency about who shaped the culture that later fed into NASA programs. They took fantasy novels and stories and satanic rituals and turned them into modern day NASA and rocketry.
There was a Warner von Braun just above Jack Parsons too.
Oh, did I miss Warner? Founders, architects tied to Nazism. Yeah, I don't know how I just completely skipped that. Warner von Braun, the key architect of Apollo Saturn V, was a Nazi party member and SS officer before Operation Paperclip brought him to the U.S. Facts acknowledged on NASA's own site and in the mainstream histories. It's names time, like NASA time. You can literally look into all of this information and you can see that the entire organization of NASA was founded on Nazi propaganda, right? The whole thing was a psychological operation right from the start that intertwined Aleister Crowley, Ace Bailey, Who else was involved? Arthur C. Clarke. Then they had just fantasy stories of rocketry and going to outer space and basically pushing the Overton window to a point where people were able to believe that they came from nothing, and then pure debauchery has spread. And this is what the heliocentrism really was pushed into the mainstream of people's homes through.
Did you want me to cover 10?
Yeah, you could do 10. I'll do 11.
Okay. Geocentrism and heliocentrism is modern and a product of the Vatican. Spaceballers are in a Catholic cult. So the ancient prelude, not Vatican made, the ideas of Earth's rotation were floated by Greek philosophers like Hercules, Ponticus, and Aristarchus, proposed a heliocentric arrangement long before Rome or the Vatican existed. But then there was a huge gap. That was the 4th and 3rd centuries BC, and then all of a sudden in the 1500s, 1543 to 1633, from print to prosecution, Copernicus publishes the Revolutionis. The Roman Inquisition later restricts and conditions heliocentric teaching. 1616 decrees against treating heliocentrism as fact, and Galileo is tried 1633. This is institutional control, not origin. Then in 1758 to 1835, there's a controlled thaw. The general ban on books advocating heliocentrism was lifted in 1758, yet specific works like Copernicus and Galileo remained restricted until 1822, allowed printing in Rome. By 1835, they were removed from the index of forbidden books. Again, central institutions decided when the model could circulate. Language and myth-making. The very term outer space enters English usage in the 1840s, attested in 1842 and 45. The shorthand term space for the cosmic void is first recorded as early as Minton in 1667. Vocabulary for the modern spaceball cosmos matures after ecclesiastical gatekeeping has softened. Then mass schooling equals mass narrative. The U.S. public education scales up in the 19th century. Average daily attendance was already 59% in 1869 through 70. And by 1889 through 90, enrollment of ages 5 through 17 was 77%, showing a system capable of standardizing a single cosmology nationwide. When did heliocentrism hit U.S. classrooms? By the mid-1800s, the American school and college astronomy texts teach the Copernican system as standard. It was a high school astronomy book in 1863. This places curriculum adoption squarely in the 19th century mass education era.
It's not that long that people have been indoctrinated, but they waited until they had the complete indoctrination system in place, and then they brought forth this.
Then we have Einstein's role in the Big Bang Theory. 1915 was when Einstein came up with general relativity.
And general relativity was a fix. It was an ad hoc because nothing that they were trying to say was adding up.
And then in 1917, the static universe gets
they brought
it's
that
a
out
little
then.
upgrade. And then 1922 to 24, using Einstein's equations, Friedman finds a non-static expanding contracting solution.
Getting to Hubble soon. We got Lemaitre, the guy who came up with the Big Bang Theory, right? The Catholic priest, the Jesuit that everybody in what do you call them? Atheistic worldviews. Their worldview came from a Catholic priest here, George Lemaitre.
Yeah, so he started doing some calculations using Einstein's general relativity
and Hubble, which
then
go ahead. No, I'm going to wait till you're done.
In 29, the Hubble, this is when they were popularizing redshift,
which was completely debunked by Alton Harp, who showed that there were local quasars in the sky that had a deeper redshift than those projected at the distant edges of the universe, therefore destroying Hubble's redshift theory. And I'll debate anybody. I've challenged Reds almost a decade ago. You can now check if you go to the Limitless channel and you type in the video Science and Reds Rhetoric, and you will find my redshift video.
Then in 31, Einstein pivots. He abandons the static model and accepts cosmic expansion. 31 and 32, they're proposing a simple expanding universe, flat expanding universe. And then, like you were saying, 1931, Lemaitre's primeval atom.
Wait, getting ahead of yourself. Adam's next. Keep going.
Yeah, so the physical origin picture, it was actually, he called it the cosmic egg.
Oh,
He didn't say Big Bang. Somebody else said Big
Cosmic
Bang.
egg, yeah.
He called it the cosmic egg.
okay. To be correct, thank you.
Punchline, the Vatican didn't create heliocentrism, but it licensed or forbade its spread for centuries, and then modern state schooling canonized it as the default worldview. The spaceball narrative is thus less a timeless discovery and more a managed belief system that rose to dominance through institutional power, censorship, permission, curriculum. And I asked it regarding the famous people. How many of the famous people considered responsible for geocentrism and heliocentrism have connections to the Vatican in some sort of a way? Nicholas Copernicus has that. He was a Catholic cleric. Galileo.
Kepler.
Brahe. Bruno.
Clavius.
Clavius. Giovanni Riccoli.
Batista, yeah.
Kirker.
Athanaeus. Roger Joseph.
Boscovich. Sicci. Thomas Aquinas. Robert Flood.
And last but definitely not,
Isaac Newton.
let's tie it all together here, Jason. Close it out on number 10.
Secret societies noted in this context. So, the Jesuits, the Secret Society of Jesus, not so much a secret society anymore, but you have to swear death oaths to join it, right? All these different characters, Jesuits. Rosicrucian connection, Robert Fudd, and Freemasons. Clear, well-sourced Masonic membership is rare among the 16th to 17th, but
they're sort of against each other, right?
Yeah, Kepler, Newton, these characters, a lot of people say they were
founding members.
So, at least 10 to 11 names in the standard geo-heliocentric story have Vatican links.
That's
as
90%.
patrons, censors, defendants, Jesuit scholars or correspondents. Jesuit astronomers staffed the Roman College and later the Vatican Observatory, shaping both geocentric defenses and modern astrophysics. Adversarial links count too. Galileo and Bruno were tried by the Roman Inquisition. Their cases are part of the institutional entanglement. And secret society, beyond the Jesuits, the clearest tie here is Rosicrucian apologist Robert Flood.
Yeah, quite an interesting debunk of the heliocentric space ball.
Yeah, it's created by the Vatican. Secret society Satanists.
As well as the word universe, right?
Yeah, so if you believe you're on a spinning space ball, you're a part of the Catholic cult.
Part of it. You're pushing it. That is what you're actually selling to people. Number 11, atoms. Not atom, but atoms versus SPVR pixels. Okay, you on the other side of the screen, you choose what's real while you're looking at pixels on a screen. Core contrast, spaceballism claim. Everything is built from atoms that are 99.999% empty space, assembled over billions of years from a big bang where everything came from nothing. What does the stereographic biblical virtual reality claim? The smallest unit that ever gets shown is the pixel. The highest resolution comes from the largest aperture / lenses, and that's the highest pixel count detectors / displays that could display. Okay. The world derived 2 observers and sampled, quantized, reconstructed, and displayed. Key fact for the audience here is that every picture of an atom that you've ever seen is a pixel based at capture, right? And pixel based at display. So both documenting it and displaying it are both pixel based. No one hands you a continuous lens scene photograph of a quote unquote atom. What you get is a measurement to image pipeline rendered as a grid of pixels, often falsely colored. What atom pictures actually are, modality by modality. STM/AFM scanning, tunneling, atomic force. A tip scans a discrete grid. The instrument logs a signal per grid point, tunneling current force. The image is a raster map of those samples. It's not an optical photo. It is a digital visualized as pixels. Electron microscopy, TEM/SEM, electrons with tiny effective wavelengths interact with a sample. Detectors record discrete counts on a pixelated sensor. Final images are pixel rasters that often involve denoising, averaging, deconvolution, and false color, right? So they turn it into CGI. Single molecule / atom fluorescence or localization, repeated frames, plus fitted point spread functions, PSFs, to reconstruct positions at the sub-pixel precision. Output is rendered pixel map and is PSF/fit is a model choice. No optical camera resolves an atom directly. Classical diffraction limits are equal to 1.22, and the sensor sampling, or the Nyquist, bind what a lens detector can actually deliver. The final is pixels, right? SBR framing, stated plainly. Smallest shown unit, a pixel. If the claimed atom is only present as pixels captured in a pixel display, you're being shown a pixel map of a measurement, not a lens seen object. Resolution is hardware bound. Bigger aperture and better detector pitch make a higher resolution / picture grid. They do not convert pixels into a continuous picture of 6 sub-pixel entities. There's no particles. They are CGI imaginations. Okay. Pipelines matter. Color maps, 3D shading, filtering, and an averaging can change the look of some of the data set. If the look changes with the pipeline, the atom picture is presentation dependent. Pixels in, pixels out. If the smallest unit shown is a pixel, you did not show me an atom, you showed me pixels. Resolution is hardware, not cosmology. Bigger lenses and denser sensors give more pixels. They don't turn pixels into a continuous movie of infinite nothingness atoms with things spinning around things that you can't observe because it's really nothing. And they don't pop in and out of existence.
Pixels versus atoms.
Jason, please take it over.
One is real, one is not.
We are at, drum roll please, number 12.
Number 12, debunk 12, the model impossibility of spaceballism. How many times have we heard a spaceballer say, you guys don't have a model?
It's McToons and Fight for the Fat Earth. Their favorite things to say, oh, well, flat earthers are never going to bring a model to the table. Well, guess what, clowns? We do, and you never will.
They say that because they're the ones holding the cards of no model. So the definition of a real model: a model must represent geometry, motion, and scale proportionally to allow accurate measurements of angles, distances, and timing. Without correct scale, there could be no valid model, only a cartoon or concept art. In every true field of science or engineering, architecture, physics, construction, optics, mechanics, scale is non-negotiable. If your model cannot be measured, it's not a model, it's a story.
Fairy tale. Cartoons.
The scale problem. Impossible ratios. Let's quantify how absurd the heliocentric scale is. If Mercury were 1 centimeter wide, a marble, then the sun would need to be 1.16 meters in diameter. Earth would be 1 centimeter as well, orbiting 118 meters away. Neptune would orbit nearly 3.5 kilometers away. That means to show the full solar system to scale, you would need a screen over 7 kilometers wide. Every planetarium, domes, and VR simulations are compressed, sped up, and distorted. They're not to scale and cannot be measured for real geometry. No real-world demonstrations exist. No lab, observatory, or university has ever built a true to scale dynamic model of the heliocentric system. Every diagram, textbook, NASA animation, stellarium render is out of scale by factors of millions or billions. Motion speeds, time scales, and light travel distances are exaggerated or compressed to make it viewable. If the model has to break scale to fit in your field of view, it's not physics, it's filmmaking. Why scale compression breaks the math? Once you compress the distances, but not the diameters or the time, you destroy the geometry that supposedly produces parallax, orbital angles, and axial tilt. You can't measure true angles of opposition, conjunction, or retrograde motion because they depend on actual geometric ratios, ratios no one can physically model. Hence, heliocentrism is unmeasurable by its own claims. So we had ChatGPT remake the scale that we had before. And this is fine-tuned where we have a sun, and we have it both in metric and imperial for both of y'all out there, either one you like. And so the sun, if Mercury was 1 centimeter, then the sun would be 2.85 meters or 9.35 feet. Venus would be 2.48 centimeters or about 1 inch. And it would have to be 222 meters or 728 feet away from the sun. And then you have Earth here. And then you have Mars. And then you have Jupiter. And then you have Saturn and Uranus and Neptune and Pluto. Then the Kuiper belt. All right. So the updated math here is that if you're using a scale of, here's the scale right here. Where Mercury is 4,879 kilometers to 1 centimeter. That right there is your scale. Then the screen that you would need to be able to show just Earth's solar system would have to be 15.33 kilometers in diameter or 9.53 miles.
Crazy.
Actually, no, this is just showing the half. So you would have to double it to be able to show the whole thing. So it would be out to the Kuiper belt, 19.5 miles or 30.66 kilometers.
Oh.
That's how big your screen would have to be if Mercury was just 1 centimeter.
Thing.
Yeah, it's ridiculous. That's never happened, never would happen. And so the reality check is that no classroom, lab, or computer monitor can render that scale. Every planetarium, animation, and 2-scale video online must shrink or stretch something, either the distances, the diameters, or the orbital speeds in order to make it viewable. Once you compress distances or alter the time scales, the geometry that supposedly explains angles, parallax, and retrograde motion and eclipse timing collapses. If you can't show it to scale, you can't measure it. And if you can't measure it, it's not a model, it's mythology. So that's
Absolutely.
it.
Yeah, well done.
They don't have a model.
They don't have
Zero
a model.
It's impossible to even produce a model for their supposed model.
They can play with math, which can be done like a card trick, right? You can do anything you want with math to show any expression that you feel like you program into it. But what they can't do is an actual 2-scale model because everything's actually local. That's how we're able to get the measurements and to track the sun to 100th of a degree per second. So we're going to put a pinned comment below where you can read this. And at some point, we'll short form these down. We'll see if time permits at what depth and detail we can get to. But there'll be more globe debunks. And if maybe someday one of these globe earthers will actually join us for a debate, there'll be even more. Great job, Jason. Well put together. Well done. It's too bad Will Duffy didn't want to go through all these things or fight the fat earth, and MC doesn't have a model Toonie Toon, his cartoons. He could have come here and it would have been great to have him answer to these questions. And we'll see moving forward what people have to say. I'm grateful to be here tonight. I'm thankful that all of you tuned in. And if you have any questions, please leave your comments below. All you space ballers out there, go ahead and debunk us. Make sure you tag us and leave a comment below and show where any of it can be refuted, because I'm just loving to wait to see if you can come up with any of that.
Absolutely. So I do feel that we're at a time now where the truth is being made real simple, real plain, real clear. And some people are just going to get it, and they're going to see, okay, they just pointed out a whole bunch of things about heliocentrism that absolutely do not work. And they actually have a working solution that does work. And so if you look in the description box, fundamental truth number 1 has to do with the grand delusion. So we were covering 2 Thessalonians the other night, and that is the book that goes into the grand delusion. And the people that fall for the grand delusion, it's because they were wicked, they weren't righteous, they didn't care about the truth, and the Creator just lets them fall into that delusion. So the people that care about the truth, this type of stuff, it's just going to stand out. It's going to jump off the page. You're going to see it. You're going to get it. And then there's a group of people out there that no matter what you show them, no matter how much evidence you get, it's not going to sink in. They're never going to get it. And it has to do with heart condition. So we just pray that this information gets to as many people so that they can be tested to be able to have the eyes to be able to see what the truth is, or they also get to make their choice and reject it and go down that path as well. So we're in a filtering time, a sifting, where people are going to be taking one path or the other. One leads to eternal life. The other path leads to eternal destruction in hell. So we'll do what we can to let people know what's going on, and then it's up to them to decide. And the time is getting short, right?
Absolutely. Thank you, Jason. Thank you, everyone, for tuning in. You're only going to get this content on the Team Yahawashai News Networks.